This is Zach Oliarnik, CS432, final project. For this video, I'm going to show you my end result first and talk through that a little bit, and then come back and hit some of the interesting things in the code after I've shown the main functionality. So, this is an interactive animation, very obviously patterned off of the Sonic the Hedgehog games. We can see Sonic is modeled as a sphere rolling down this ground plane track. We have the skybox, and we have several ring objects that are all rotating themselves. This track is made up of 3 lanes that can be switched between, and here we'll see Sonic go around the loop at the end, which was a very interesting challenge that I'll be spending a lot of time talking about. But Sonic can switch lanes by using the arrow keys left and right. He cannot, however, switch any further to move off of the plane, which is cool. I can also control the camera. This is an orbiting camera, which means it will always spin around centered on Sonic. And then whenever I've switched to a frontwards facing view like that, wait for the loop, and I actually reset the camera whenever I start over. So I'll come back here, and whenever I'm frontwards facing and use the arrow keys, you still move in the direction on the screen that you're expecting. So I put a check in to compare the relative Z positions of the camera and Sonic. You obviously see that as we collect rings, they vanish. That's done by doing sphere collision detection. Sonic automatically realigns himself to go over the loop no matter what lane he's starting in before that happens. And the last piece of interactive functionality here is whenever you click on him, he will jump, which allows you to collect these rings up in the air. That's done using picking, so clicking anywhere else has no effect. Lastly here, if I press the... well, we'll wait for the loop again. Alright, if I press the space bar, I switch into a 2D mode, just like the classic Sonic games. This provided its own challenges, mostly with the skybox not working and picking not working exactly the same in an orthographic projection either. So I was able to come up with some workarounds to solve that problem. Also, we see sometimes, because we're in orthographic view, we don't really know what lane Sonic or the rings are in, so it'll look like he won't be collecting them from the side just because he's not in the correct lane. You saw that the loop camera is still automatically switched to no matter which of the 2 other cameras you're in whenever you start that. So that's pretty much everything that my game can do. I do mention in my README PDF that I was going to attempt looking at shadows because that fit the aesthetic here the best, but I simply ran out of time to be able to implement that. So because this is an animation, it's done mostly using a lot of timer variables, Boolean flags to set whether Sonic's on the ramp or on the loop because he needs to move differently whenever those things are true, and speeds, and like here a max jump variable, and then controlling the current lane that he's in. That is in order to make the movement be uniform as he's moving back and forth between lanes or jumping, and not just look like he's teleporting. That basically defines how much he should move at each time step in the animation callback. So I define my stuff. Skybox and sky plane are 2 different things, which I'll talk about in a second here. Set up my 3 cameras. This one, these magic numbers defined just by rotating around the camera and figuring out what the best view to look at the loop was. And then 1 light that acts as a sun acting on the entire scene. My keyboard callback, switching the 2 main cameras back and forth using the spacebar, and doing that orbiting that I showed of the main camera around Sonic using the Z and X keys. Arrow key left and right moves Sonic's position in the lanes, doing, as I mentioned, the check with the sphere's relative Z position to the camera, as well as not allowing him to move off the edges of my ground plane. And finally, the mouse callback, implementing picking the same way as we did in a previous assignment, but with an added check to see if I'm using the 2D orthographic camera. this this was the result of some research trying to figure out why picking wasn't working in 2D, and now that I've read about it and figured it out, it makes perfect sense why our tested ray needs to start with a direction of the camera's forward and then an origin point of the place on the screen that was clicked. This is obviously different from the perspective projection, where we're doing the other version of that. But again, makes complete sense now that I sat down and thought about it. In my timer callback, I'm constantly counting up my timer to know whenever I've reached the end of the animation, which is this reset time. I set the camera back, set Sonic back to the center, and then reset each of my drawables. For Sonic, this basically does teleport him back to the beginning of the area, and for the rings, it does some other cool stuff, which I'll talk about in a little bit. And then this is another cool trick. If I do the modulus of whatever the current time is and the total reset time, and I end up with either the cam switch time, the ramp time, or one of these other things that I've defined up above, I know that that's that much time into the animation. So whenever I've determined it's time to switch the camera, I do the modulus and check and see if it's at that time, at which point I do what I need to in order to switch the camera. Similar things, setting variables to control whether Sonic's on the ramp or on the loop, and if he is, then I need to call the sphere methods that tell me that I'm there. And I'll get to those in just a second. Jumping and changing lane, as I mentioned before, whenever the keys are pressed, they set my number to be something other than 0, and then at each animation time step, we count down back towards 0, so that we know that we're only doing something weird or a different type of motion whenever those things are not 0, and reducing them to 0 as we do that motion. Rings are constantly spinning, and that's all here in main. The camera, I just cut out a lot of the different movement stuff because all I really wanted was that orbiting motion, but I did set some stuff to say whether the camera is 2D or not and whether it can move or not. And all that really helped me with was this set target function. So at every draw call, I reset the, basically it's the at position, although I'm not calling it that. And that's where the camera is looking at, which is always the sphere plus a set Y distance. And the reason why that was necessary is because jumping caused some weird effects if I was always looking directly at the center of the sphere. Instead, I wanted to be looking at a fixed Y and only update X and Z as the sphere moved. And nothing else too interesting there. Okay. The skybox implemented exactly the same as it was in a previous assignment, with the one caveat that if I'm looking at the 2D camera, I don't want to bother rendering this. And in my sky plane, which is just an image plane placed at the right place in the scene, it's the opposite. If the camera is not 2D, I don't want to render this. So it turns out that skyboxes and orthographic projections don't work very well together either. So to solve that problem, I just determine whether I'm looking at my 2D camera or not and plop a plane into the scene instead of the skybox if that's the case. Nothing interesting to say about my ground object. It's just a rectangle with textures defined so that nothing gets skewed really badly. The loop was a lot more interesting though. Rather than try and geometrically define the loop, I used my 3D modeling experience to go into Maya and make the loop myself. From there, I was able to just read the list of vertices and a lot of them, throw them in together. You will notice that the verts are repeated and set into the groups of 6. This is basically me manually using the make quad function to define everything in the correct order that it needed to be. The textures were also a challenge. I did a similar thing, but again, I had to account for scaling and making sure the textures weren't distorted. So that's another big, long, ugly list of verts in there. But still easier than trying to come up with a mathematical formula for it. The rings, on the other hand, were pretty easy. I did it parametrically, but then I also had to use facets to make the GL draw triangles command work correctly. Basically, I needed to use the parametric equation, but define the verts 4 at a time so that I could still make a quad out of them. Numbers like the outer radius and the inner radius get plugged into that formula, and so I can define those. You'll notice that I'm creating 27 different rings, and each instance of the ring is linked to a position in the world space, a Boolean saying whether or not that specific ring has been collected or not, and I'm also storing a reference to the player. So why am I doing that? Because whenever I go to do my render, so I'll start down here, I was not able to use true instancing as we discussed in class, but rather this pseudo instancing where each instance of the ring shares a VBO and all of the vertex and texture data, but different vec4s for their position and whether or not it's collected. So whenever I go to do my render, I have a loop here for my number of instances. If the ring has already been collected, don't render it, and in fact don't even bother doing the collision check because we don't care anymore. The next step is to do that collision check. If I find that it has been collected, I set collected to true so that I don't do this anymore the next time, and I don't render it this time either. Otherwise, I reset my model matrix based on the position of the specific ring that I'm looking at, and then do the draw call. And I'll do that for as many rings as I have in the scene. So, the test collision here you can see is just implemented using the bounding sphere. Obviously Sonic is a sphere himself, so that's very simple, and then because the rings are constantly spinning, the easiest thing to do was to just put a sphere of the ring's radius around the ring and just know that it's close enough. If you watch the animation, you really can't tell. It still looks good doing it this way, so I didn't lose any sleep. You also notice that I have a reset function here, which is cool because whenever the track resets, all the rings turn themselves back on, so you can have another chance to recollect them. And I also call set positions again. So set positions says for every set of 3 rings, pick one of the 6 lanes, 1, 2, and 3 across, and then the same ones up in the air, so Sonic would have to jump to get them. These numbers all defined based on my track length and width. And then use a Z offset to create the groups of 3, and then another Z offset to space the groups out along. But the point was, I recall set positions every time I reset my game, so the rings will actually be completely randomized every time the animation loops, and that's cool too. The subdivided sphere, the sphere itself is drawn and created as it has been for the past couple of assignments. What I did need to do here though is define the different special movements that the sphere can do. So the normal roll just rotates it in place, but if we tell it that we want it to move, it also moves down the track. The jump and the change lane I mentioned before as things passed in whenever my number is not 0, and then that gets multiplied in here to make it slowly move over and make sure that it doesn't look like it's teleporting. Whenever I reach the ramp, in order to go up the ramp, I need to translate it in the Y in addition to the normal Z translation that's accounted for up here in my roll function. And then finally the loop, which took a little bit of thinking about it. I actually calculate the angular velocity here to figure that guy out. But then I use the loop position and the radius taken from the Maya model in order to change Sonic's Z and Y positions, sine and cosine, make him look like he's really going in that circle around the loop. This is important because whenever I'm calling loop, I need to call my roll function with Boolean set to false, so he's not still trying to move in Z and overwrite the Z that I'm doing down here. So I don't know how I'm doing on time, but knowing all of that, I'll just let you watch it one more time. Sonic's got jump into collect rings, moving back and forth, switching the camera this way, switching the camera this way, where jumping still works, and eventually coming up upon the loop where we will see him follow first up the ramp and then the sine and cosine movement to get around it. And that's all that I have to show you. So it's been a great class, and I really learned a lot, and as you can probably tell, I think that this is great for the applications in gaming, which is what I'm interested in. So thank you.